team name is the Restaurateurs, and we consist of Ethan Stefanis, Jolena Jasperson, and Jacob Patak. Our goal with this project was to implement 2 different video compression algorithms, run length encoding and Huffman encoding. The file format we used is YUV.
Yeah, so we chose YUV because it has no header file, or it has no header section, and it has no audio information. So it is very easy to apply these compression algorithms to and decode and whatnot. And so here's, for example, one of the files that we were using. It's clear, so no audio. It's also like raw pixel data. So the only compression being applied is our compression algorithms, which also means this takes up a lot of space for the quality and time that it is. But yeah.
So if we run our program, it first asks the user if they want to do RLE or Huffman for the compression. We're going to start with RLE to demonstrate how our RLE works. You enter the file name, and then you also enter the file width and height. And this is important for RLE encoding because the program needs to know when each row ends and when each frame ends in order to encode and decode it. We implemented 2 different methods. First, the lossless, which is only the RLE. And it encodes runs of repeated values, which is difficult on these types of video files because there's lots of unique pixels. So there are not many unique pixels or not many similar pixels to be stored in these runs, and it ends up increasing the overall size of the file. But it keeps the quality the same. So this is a lossless way of doing it with RLE. And it's not the most efficient, really, at all. It doesn't achieve the goal, except for keeping the video looking good. So we also implemented a lossy algorithm, which adds an additional function, quantize. And what quantize does is it identifies pixels that are similar enough in color to a certain threshold. We're going to use 16 as it's a default threshold. And it will treat those pixels that are similar as the same. And it effectively reduces the file size significantly, in this case by 89%, without really noticeably reducing the video quality, even though if you were to play them side by side, you would see that the new video is slightly more posturized. But this is this is a way of doing it without really sacrificing the quality of the video very much at all. It's a very insignificant change.
By the way we're actually playing these videos back on this YUV player, it would not be able to read our encoding since it's not a supported encoding it has. It's just one that we made. But we're essentially, after we encode it, we then, using only that file, decode it back and to get the original file back, thus showing that, we didn't just like delete information from the file in order to reduce the file size. And that's the same thing we're going to do with Huffman. In order to actually be able to play the video while having it still be encoded, we would have to have implemented essentially our own video player, which we did not have time to do in this project. But yeah, so here is the Huffman encoding. So we're going to use different person here. We're going to use Stefan. The way this works essentially is it uses a priority queue to store how often each data value is used in the video, and then the ones that are used the most often get assigned a really small binary code, while the ones that are rarely used will get assigned pretty large binary codes, but it does not matter because they're not used that often. And on average, this results in lower space usage. So here you can see the file size for Stefan is reduced by 11.5%. Stefan is a pretty big file, like 1 megabyte for just this few second clip. So if we go here, so I guess here's the original video, which we got to change this aspect ratio for. There we go. So that was the original video there. And if we play over here, let's go stored it somewhere else for some reason, but main.decoded, it is the same video. No information lost whatsoever, but it was encoded in a format that was 11.5% smaller. And yeah, I mean, I think that is it, that's the project. Have a good day.